So we're back at the tube barn. Last week I said that I was gonna start from the power section, inverter, and then go from the preamp down. I really wanted to do that, but I cannot do that. I have gone through my parts and realized that I am completely out of 0.1 UF capacitors. So I actually cannot do this. And I don't want to do it all except for that section. So it is what it is. It's starting to rain. Kind of in a cranky mood. I wasn't going to do a goddamn video today. But I've decided that I'm not going to let the kid do this. Are you ready? Yeah, I'm ready. You sure? You're going to get it on there, right? Oh, no, I have it. I know what I'm doing. Okay, so I'm going to talk a little bit, and I'm going to let him at it. You can see I got my bus bar in here. Never done one on this type of situation. These the word is escaping me. These little posty things. I can't remember what they said. I don't. Whatever it is. Turret. So I have it there, and you see that I have all my grounds in here, but I think I'm just going to go directly with the bar. I have one. I forgot to drill a hole right here for a ground, but I think I can get that and then go like that. We should be fine. So let's see how this goes. Okay, kid. What are we going to do first? I'm going to let you handle this. You're going to get it on. And I think you got it. You ready? Yeah. Yes, I'm ready. Okay. It's all you, kid. Okay. We need to connect the input jack to here. This is the input line, 68K, and the ground resistor. Then we will connect it to the tube. Okay. We need a 68K and a 1 million resistor. We have different kinds. The blue ones, which are cool because they're blue, but they're also cool because they're metal film resistors, which are the best for signal as far as we are concerned. You want to measure the bend. It's very small. Also, I cannot see. And then we cut it. Do you know what value these are? These are, I believe, quarter or half watts. I'm not sure. They're very small, and the bend is not right. Yeah, quarter watts and half watts are fine. Quarter watts in a signal path like this, completely acceptable. Oh yeah, yes. That's why I chose it. Okay, cool. Yeah, I'll stop bugging you, man. Okay, now we need the 1 million. Make the bend. Then we cut it. Ah. If my hands were smaller, this would be easier. I don't like that bend. I'm going to change it. It needs to be shorter. Now we need the input to go to the input jack. This is a shunted jack. We will need to do a few more things to this, but we will not do that right now. We use the blue wire. It is a signal path wire. It's a little long. Okay, we will solder it here first to complete this one. Remember, you need to solder away from your heat source. But first, control your items because they're irritating and they are moving. We will leave him there and put him in his place in a minute. Tin. Yes, that one is good. He needs to go into his hole. Go in there. Now, this one is the input. This is shunted. This is the shunt. No, this is the ground. This is the shunt, and that is the input. We will need to connect the shunt to ground directly because we will not be using a resistor as we will on the output jack. Okay, that one is good. So now what are you doing? Oh, we connected in and it looks good. We drink beer. What? Well, those are your rules. Okay. Okay. Now what's gonna do? You need to stop. I'm doing this. Okay. Jesus. Okay. We're going to connect the 68K resistor to pin 2, which is the grid of the 12AX7. Actually, we're going to do it to 7 because it's on that side. 7 and 2 are the equal on the both sides of the triode. And I'll put this one in first. No, maybe not. One, two, three, 4, 5, 6, 7. This is the cathode. That's 7. This is not used. Okay, well, we're good. I thought it was the wrong pin, and so this is too short. We will try another one. I don't like this. I don't like this stranded wire. You tell me about it, kid. Stuff sucks. Let's just solder him in. The insulation burned a little bit. This wire is not so heat resistant. Be careful not to pull the pin. We need to hook this to ground, but because you forgot your hole, we need to go from here to there, and then we're going to ground it here. Oh yeah, you know, screw up. It is what it is. And which one is that? That one is the 1K off the cathode. All right, let's get a 1K. Shh. Okay, shut up. That one is too short. We will find another one. I'm gonna have to use the 1 Yes, it is not necessary, but we use what we can. Too much is better than too little. This is the cathode resistor on the first stage. It is 1K. That is what was chosen. So we need to get a ground wire from there to the bus line. It would be fairly short. But we can cut a lot of insulation off to get a good wrap. The rain, it is annoying. Fuck. That is hot. With these you can wrap it. Hopefully this will solder easily. Yes, it did. But you need the ball of solder on the tip to make it conduct properly. Now we have the first stage almost ready. We need to run a wire from the cathode to the cathode resistor. A little much longer. And twist it and see if it will bend. And it is number 8. 1, 2, 3, 4, 5, 6, 7, 8. These holes are very small. Hmm. Mm-hmm. Now we will connect it to the cathode resistor and we should be good. You know, you need to talk a little bit more about what it is you're doing. I know, but maybe I don't want to. Well, yeah, well, that's not the point of the video, guy. I mean, you gotta give the people a little more information. Okay, fine. You can talk to them, and I will do it, and we will separate this. Okay, okay, sounds good. But I need to solder this, so be quiet. Okay, I'll be quiet. Oh shit. That will be a little more. Man, it dropped. Exactly. It dropped. It's not full. Oh shit, that was, yeah, you fucked up my solder. I know. Oh, and you ain't got it until it's all the way cool. That was pretty hot. Okay, the first stage is done. Yeah, okay, so the first stage here is somewhat done. Or at least the input side of it is done. We have the input jack coming into here, which is, this is the 1 million ohm resistor, which grounds it. Your grids need to be grounded as were discussed. Normally it's 1 million, it can be less. Your pots can be your ground. I've seen, it can be 100, 250, but generally they like to use 1 million. And that's what we're doing. So this is your 60K. It's a metal film resistor, which is extremely good for signal. They will not flavor it at all. It's pure, let your signal in. You can use different things. Carbon comp, the old school, if you want to maybe muddy it up, if that's what you're looking for. The reason for the 68K resistor, and if you can, they say, get as close to the pin as you possibly can. This 68K resistor is what stops the radio waves. If you've known people who had amps that sound like they had a backup band, the radio playing through it, that is what that stops. It stops those radio frequencies from coming in. It can affect your tone a little bit because you're taking just a tad bit of highs off. So it is a compromise. And that's also why you use shielded cables, which you're going to ground your shield there on here. So we're going to leave this for a little bit. What we're going to do now, we're going to send the signal to where it needs to go. Okay, hold on. What about that? This is the cathode. Yeah, that's the cathode. You told me to shut up. You need to put your cathode resistors in here. Oh, that's right. Okay, please. This one's a bit more complicated. Please explain again. Okay, this is where we're going to have our cathodes switching. We can't completely hook it up yet. We shouldn't even have that soldered in because that should be soldered last. What we're going to have is going to have our cathode resistors, our cathode caps here. Then we're going to send some resistors into here. I was supposed to use 5 million ohm. Apparently I don't have any. We're going to try 2 million. This is kind of a guessing game of what is the perfect ohmage, because the reason why we're doing that, because when you switch over, you don't want it to pop. A lot of times you can just straight up ground it. I don't know if that's the best way. You ground it that way, it's completely discharged, but then it does have to recharge. It should recharge pretty quickly, but it could have put a little strain on it. So you put these resistors that technically connect the capacitors to each other, so they kind of bleed back and forth, and so when it goes, it doesn't pop. Because you realize this is a electrolytic capacitor and it's charged up. Normal capacitors can do it. These ones I think are probably more prone to do it hard. So we're going to do that. We're going to try 2.2 million and see if that works, because we won't know until we try it. We can always come back here and change them. Another thing I thought I ordered, or maybe I did and I can't find it. I don't know. It is what it is. So we're just going to connect that here, and we'll connect that in there. Later, actually, I can't even, we're going to actually, now I think, we're going to just straight up bypass this first stage caps, because I need to actually build that board and connect it all in there, and I don't want to start soldering stuff or leave this unsoldered and cause problems. So that first stage cathode cap is not going to get done right now just because of the complexity of it. We're going to move on to the second stage and drink some beer. Yeah. Put your glasses on, dude. Your glasses. Okay, so what do we have here? You have a cheat sheet. Okay, it is. Okay, we need to. This is where the signal comes back. So we need to take the signal from here and go back into it. So, and what's it come back off of? It comes off of 6. It goes into 7 and out 6. The same way as it goes into 2 and comes out 1. All right, cool. So, get on, boy. Please don't. No, I'll fuck that. Okay. 2. Okay, 2. 6. Watch out. This is why we bin them. All right. So here is the dilemma. Do we wrap it around here, or we hop it up in the air? Because this is an upside down amp, the gravity will hold it up, and this will be a shorter run because shorter runs are better. Damn right. Exactly what he said. You want your runs as short as you possibly can. It lessens oscillation, any pickup from something else. I just dropped something in there. Pickup from something else, and all that stuff. So look up oscillation. All right. Don't want the camera. Okay. Okay, now we have it hooked to, the plate is hooked to the plate resistor. And now we need to put the capacitors in there. And the capacitors are 0.022. I can't see shit out of it. I like these ones better. They are smaller. Yeah, I do too. Though, like I said, back when I was doing this, I need to redo the board. I don't. It's look how small that is. We will be fine. I know we'll be fine. We will do it like this. And cut it because it's too long. What are you doing, dude? Wrong one. I know. Okay, fine. It was wrong. It was my fault. Don't worry about it. So what we're doing... Yeah, actually, cut it perfect, dude. Didn't even know it. Thank you. Okay, so what we're doing is we're running the 0.022 to here and the 0.022 to here. The reason why it is separated because of the gain switching. And here we have the resistor that's going to drop it, the attenuating resistor, drop it in the capacitor. So then you're not actually going to put it on this thing, are you? No, you are not going to do that. Okay, so we just need to avoid this. These two originally were not grounds. These go to the pots. It's very confusing when you don't look at the sheet, when you just see a bunch of holes. So yeah, we have to remember what we're doing. So we're going to jump here to here. Well, to here. Then from here is where it's going to go into a relay. So we're going to skip the relay for now because those boards need to be built. I'll do another video or something on that, hopefully before next week, so maybe I'll have 2 videos out next week if I can get it out and the weather will permit. Okay, so, but this bar will still be used as a ground bar for the pots. Okay, yes, so I need to finish this. They're pretty close. these are technically not polarized, but they technically are polarized. It takes a oscilloscope to verify which side is the positive. Okay, so we got that. So what are going in now? We need the you did this, but it is not even. It is a 470 and a 220. Okay, cool. So we got 470. Do we have 220s? Yes. More metal film. Okay. Need to remember the sides of which ones they go. It is 470. Now for this build, I bought a lot of metal film. As much as I'm building a Marshall, I didn't want to flavor it with resistors. I want to see what the amp does as far as the circuit on its own with gain and the EL34s. And we're going to see what it is. And I don't really want to flavor stuff with noise. I mean, there's no sense in adding noise. I mean, your noise is going to be your secondary harmonics and stuff like that from your overdrive and distortion from your tubes. Okay, what are you doing? We need the capacitors. So they're matching there, right? No, we are going to do a 470 and a 330 if you have them. Okay. All right. 330. Or 70. Silver mica. So these ones just split out like this. Okay. Stop. Stop. These have very, very thick leads. Yeah, they do. So that's gonna be a problem with that buzz, isn't it? Yeah, I don't like it there. Actually, we'll be okay. Okay, good. I will solder it in. Maybe we'll do this one. 330. I chose the 330 because normally you got a 220 resistor, a 470 resistor, and I'm referring to Ks, kilo ohms. So you jump the same that you're losing because your 470 is going to kill your tone significantly. The high ends are going to drop. So you jump over the equivalent in picos with this capacitor. But I decided I'm going to fuck around, and there's a 220, but I'm going to jump 330. Let's see what it does. If you know, comment. figure because this one is going to be my gain. You got your clean and your dirty, or if you have your dirty and your dirtier, or lead and rhythm or whatever you're doing, that this one is going to have a little bit more high end, I'm hoping. This will probably act somewhat as a bright switch automatically. So let's see what happens. All right, we're good. We need to connect it to the gains. All right, go connect them to gains, boy. Don't call me boy. I'm sorry, kid. No, we need to do this one before we forget. All right, now we're connected to the plate of the first stage. Please tell me how it looks. Okay, let me look at it. Solders aren't bad. This solder is definitely a little fluxy, so it kind of goos a little bit, but I think the solders are looking fine. It's nice and warm out here, a little humid, but I think we're looking good. You're doing good, boy, kid. All right, so let's do it. Get it going. Okay, we're going to hook it to the gains. These two are the gain knobs. It goes in here, out here, and this is ground. If we can, we will try to ground it to there as well. Okay. These are not tight enough. Okay, so let's get these babies in here. Okay, we will go to the first one. I don't like that. I don't like it either. Spray wire sucks. I call it frayed wire. Stranded wire just turns into a bunch of frays. Okay, we will go to the first one. Now we drink beer. I'm with you, boy. Let's drink some beer. Kid, jeez. Well, I don't know why I'm doing that. I'm sorry, dude. You sound like the fucking redneck. I know. I'm sorry. I just got it in my head for some reason. I do apologize. Thought that was going to be shorter. So did I. Yeah, I was thinking that was going to be a little shorter. That's fine. That's fine. Bring it down like that. It'll be good. Okay. Now we do the other one. If I can find the glasses. Okay, let's do this one. Okay, that looks good. That was number 2. All right, that was a good one. Thank you. Now we will ground these. Just the thing, if you do want to actually ground something to the back of these, before you install them, sand them a bit. Make sure there's no writing that you don't want to get rid of in case they're not properly labeled on the front. You're going to have to rough them up, because if you don't, good luck getting anything to stick to this thing. If you're not actually going to ground it to, I'm sorry, if you're going to ground it somewhere, you can just ground it here. This doesn't need, the chassis will ground, but it's not a secure one. Corrosion, time, movement, so it's just touching, not touching well. So you want to ground there to there, and then go to a ground. We're going to use this bus bar. I'm hoping none of this is going to interfere with the crap we're going to do with the relays boards. That's what I'm worried about too, is that's why I want to do this first. Where am I going to place my relay boards and stuff like that? That is going to be fun. It's not always easy, and sometimes it's downright irritating. Yes, and let me work. I know, I'll let you work. Come on, it's all good. Okay, stand up. Dude. This is a little ugly. I know, but it is what it is. Okay, we got this, kid? I think so. This might not work because we did not rough that up. Okay, we didn't rough it up. The hell? See that, kid? Yeah, I see it. We didn't. Here. Let me show you guys something. Take this off. This is something I can't have anyone, or I haven't had anyone be able to tell me why. Is these things come with these little bars on them. It's pretty much just break them off. I don't know why they're there, what use they have. They're pretty much annoying. I don't see any purpose in them. Because if you try to put it in there, they just sit in freaking crooked. I don't know, it just makes no sense to me. Also, it's not essential that we solder the back of this. As long as we get this in here, we should be good, but I'm going to try. Sometimes I gotta cook it a little bit. We'll see. Now we need to put it to the bus bar. Okay. I think you need to bend that down, guy. I know. Ah, shit. Yeah, you fucked up. You fucked up. You're the one holding the thing. God damn it. Meant to strip it. I just chopped it. Son of a bitch. Can we move this over here a little more? Yeah, I think we can barely do this. Oops. We can bend this a little more. Oh, son of a bitch. I don't want to have to change this wire. Okay, yeah, it is. Got a hook on there. Hook him off, damn it. Damn it. That is hot. This shit happens when you're building amps. That is hot. Hope that's okay. It clouded just a tiny bit. Not the best solder in the world. If there's an issue, we'll come back and we'll completely change that. We shall see. Okay, you were distracting me. It's irritating. I'm sorry. Okay. Continue. I am continuing. Okay, now let's do it. Now we need to ground it to the bus bar, but not screw it up. You will wrap it on. Very good. That is, has a lot of contact. It is not beautiful, but it is functional. Okay, now we're going to move on. We are going to put the signal into the next grid, but we cannot connect it because we do not have a relay board. So, but we will do that so we stay consistent. We use the blue wire. And that is what we're going to do. It is number 2. Good job. You didn't burn that cable. Thank you. So we will leave it long because we do not know where it's going to land. Right there, out of our way. Out the jack hole. Okay. Now we will do the cathode. So we're doing the cathode. That was the second stage. The second stage that we're wiring now. It's 3 stages. There's 2 plate follower stages and 1 cathode follower stage. This will be its own stage. And at this point, we don't have any more cathode capacitors. They don't really work well. You don't see too many plans with them. I tried it one time and it just made a really bad humming. It just muffled it and made it very, very weird. That could be a weird mod though if you just wanted to get in some crazy crap to have it turn on a cathode cap on a different stage. This just does not want to go on. Trying to make it flat to go in easier, but it seems worse. A little bit, but getting it done. Just watch those side frays. Now we're connected to the cathode resistor, which is a 12K, because we're going for a cold cathode, which will be compensated by the 820 ohm resistor in the cathode follower, or the plate follower of the cathode follower. Okay. level statement. Okay, we need a 12K resistor. Does not need to be this big, but that's okay. That is what we have. Did you forget something? What? What? It goes there, and it goes to the ground. We're gonna use the bus bar. Oh, damn it! Damn it! Stupid! No, it's cool. Don't wig out. You're doing good. It's just a mod. We don't do this. You're not used to it. Okay, we will do it again. Okay, we will do it. We need to measure. Yeah. And we'll just a tiny bit off the end. There we go. You could cut too much off. I know. I see this. You happy with that? No, I'm not. I'm not happy with this. Yeah, I say we take it out. Okay, yes. You will do it again. Okay, we will do it again. The solder is mostly gone, so we should be fine. This is one of those times where I'm going to ball it up just a little bit. See if we can get it to drop in, just because you can't quite hold it, and it's burning the living shit out of my hand. Yeah, we're good. Okay, now we're going to spin it. I haven't seen these. I think I mentioned them. They're jeweler's pliers. They're really nice if you want to get a nice round turn. I just gotten used to using the Hemos. I like them. They're kind of an all-purpose thing. All right. Okay, we're going to bring from the plate and move it into the next stage. We will need a wire to the 100K plate resistor, a 0.022 capacitor, a 1 million ohm resistor, a 470K resistor, and a 470K capacitor. It's going to go here and go back out into the other two. So first let's do the wire. Okay, we will run it to here. Then we need the capacitor. I do like these ones are a lot smaller. If you do not understand why these look better and smaller, the other orange drops are like this. They are very big and they are very bulky and they are hard to do other things around. They are a different style in fenders, but they're good. But for this build, it is too much of a mess. These ones are simpler. This goes directly back to the tube. It does not connect to anything, any pots or anything. It is a signal path directly back to the tube. It is reduced by the 470K resistor, which I will get. These are very soft. They're easy to use, but difficult at the same time. Now we need to compensate with the capacitor. Okay, yes, looks good. We will need to ground this. We'll put a 1 million resistor. I will remember. I remember to put it there. You can cut it. We will. It is there. 1K plate resistor, sorry, 100K plate resistor goes into the 022 to here. Then it comes back this way, and the million ohm to ground, and that goes back to there. It is very hot. Okay, I'm interrupting this video. When I was editing it, I realized that there was a mistake. It's not a mistake in the schematic. It's not a mistake in the circuit. What happened was when I transferred the schematic, the circuit, onto my board, I made a mistake. And when I was editing, I was watching it going, hold on, that doesn't make any sense. So I looked, and now, right here, it goes here, it goes back out there. You know, this is the 0.022 capacitor. Then it hits the 470K resistor and goes back in there. It's supposed to have is the voltage divider. I had set it up here. This is doing nothing other than now we have, instead of a million to ground for the grid, now we have 1.47 million ohms to the grid, and it's doing nothing. So what I'm going to do is I'm going to disconnect this. I've been wondering how I'm going to put that. I think I'm going to jump it from here to this ground here. Because if I try to jump it all the way to ground here, there's a good chance it's going to short out into here when it touches. So that's my plan. I'm going to put the little section of the circuit on the screen to show you that it is in fact a voltage divider that we're trying to do. I believe during another video I discussed why I went to change this to 1,000,000 instead of, well, over here, this resistor to 1,000,000 instead of 470. I didn't want to half it. I wanted to just do a little less than half it, just to give it a little more drive. So that's what we're going to do real quick. And as soon as I'm done with this, we'll go back to the video where you're going to see where I did the rest of this. But I just wanted to make sure that you knew this was wrong, and the fact is I needed to fix it. The first thing we're going to do, you know, I'm not even going to do that. I'm literally just going to cut this out if I can. 1 second. I have no idea where those cutters are, so maybe I'm just gonna see what I can do. Yeah, there, we just destroyed it. Even easier. That is now not part of it. I didn't want to mess with this solder, so I'm just going to bend that in there. This way, we're not messing with the solder, but we are going to have to get that wet and get it in there. So let's do that. Okay, a little far. Okay, that'll be good. Maybe a little farther out, went too far. Okay, cut them up. You have to stand these up a little higher than I want. This is where I said, when you're gonna or desolder something, you're definitely gonna need a little ball of solder, because if you just put a dry soldering iron there, it's probably not going to get wet. Hot, very hot. Okay, whew, shit. And once we get it in there, we can resolder it all nice and good. Right now we're just trying to get soft enough to get in the hole. And these things do get very hot. Okay, let's try this one. See how it's not getting wet. Oh, I dropped my solder on the ground. We want to get that tip, the ball of solder on it. That way it'll conduct the heat. It doesn't want to go in there. It's a little full. Damn it. There we go. Now it's in there. And we can go and give it a real solder. Now it's mixing with everything. Everything's good. To this side. And everything should be good. We're going to give it a second. We're going to check some continuity. Make sure it did in fact solder. And we do in fact have continuity. See, we got an ohmage going on. You got no ohms, so that is a good connection to ground. Right there, 9.952 million ohms. So we are good. Remember, these things have tolerances. When you see them, it'll say tolerance 5%, 1%, 10%. That means that it may be off a bit. This is 0.95 million, so it's got a little bit of a variance in it, but it is in fact, we are showing, actually I want to see this. What do we get to ground? Just from right here. 0.96, so that's pretty good. It is making it through here. It is getting all the way through. We have good continuity with that resistor. You can go here, 470, so 470. I can't seem to, there he is. 0.467, so that's pretty close. You're going to be off a bit, but like I said, it's not a perfect thing. You can get things with 1% tolerances that are really good. Not really necessary unless you're doing precision electronics. Actually, I'm gonna just check this one because I just want to make sure we're good. Yeah, 0 ohms, cool. This was kind of a crappy. Yeah, we're good. So I just want to add that in there. Back to your regularly scheduled program. Okay, so we're almost about to hit the cathode follower. This is where things get a little different when it comes to the plate. So we're gonna hit it. We had to take a break, you know, gotta get beer. But this is schematic of somewhat what I'm building, not exactly, but no, that's a different amp. But I can't show you because I can't get in here. I'll try to put it on a screen. I think I showed you this in a different video, but the cathode follower, there's some safety stuff in it, and I've only been recently doing this. I think I've only done it on that amp back there. So it is definitely not in my head. So I'm gonna have to reference that to make sure that I'm doing it right. The cathode follower can get a little tricky. So making sure we're not screwing up. What it is it's some safety stuff in there, because what happens at startup is it can beat up your tube during a cathode follower. So it's just kind of it's not quite a slow start, but it is definitely a safety feature. Okay, kid, you ready? Going to get back on this? Yeah, I'm ready. Okay, so we're going to send the signal to, where's my glasses? To the tube. We are once again going to use this side of the tube. So we're going to hit 2. We're going to hit 7. 1, 2, 3, 4, 5, 6, 7. No, we connected to here. You can hear these things rattling. I believe once you get the tube in there, it'll tighten up, so it's not going to do any of that. Okay, that looks good. We need to move it from the other side to here. Yeah, the kid and I had a discussion. I'm gonna take over for this. This is a little complicated, and so I just want to make sure we're all good here. Good learning experience. That's why you're all watching. So, come on, kid's doing a good job, right? Come on, comment. Comment. The kid's doing a good job. I mean, he's freaking little kid. He's got his issues. He's smart. Come on. I want to hear some comments. Come on. Now that dickhead shit either, because I'll fucking just tell you to fuck up. So anyways, this is going to get a little fun. The fact that it's a cathode follower, we build it on the tube, and we have this safety stuff, this is going to get a little fun. Because getting the little components in there is going to be a slightly little irritating. Like I said, I've only really used the safety thing once, and so I remember it wasn't that fun. I'm going to move these wires over here. So anyways, what we're going to do, I'm going to cut this one. I'm going to move this up. Let's get the center stage. Make sure the camera's good. So, let's get in there. What we're going to need, we're going to need a 100K resistor. This is our plate resistor. There's another thing I've used, and I use it in a I don't see it here, in a preamp. It's a mic preamp. And I used 150K on the plate. And this is on the first stage. Remember, you're jumping from one half of the tube to the other. Remember, triode, it's two halves. You're jumping it over. But you're using a 100K on the first plate. It exits the plate. It goes directly into the grid of the second half and comes out the cathode. Now, the safety thing puts a couple things in the middle. But I use a 47, I'm going to use a 47K on the cathode of the cathode follower. And I put that in one of my videos. All my videos are numbered. If you want to learn what I've been saying, so I have to repeat myself, go watch them in order. They're in order. I have numbers, video 1, then they have a name, whatever. So the 47K, instead of 100, you'll see it's like 100 plate, 100 cathode, 100K resistor is what I'm referring to. But the 47K gives it a little bit more of a crunchier than a fuzzier tone when it comes off when you're talking about your gain, you're overdriving your tube. But you can use like a 150 and a 1K. It's really good. It gives it a nice tone, especially with mic pre's. But this, we're going, but it kind of kills the gain. I believe the current, whatever. It's one of those things. But this one, I'm going to use a 47K because I want a bit more crunch, a little fuzz. I don't like the fuzziness. If you're going for fuzz, then use the 100. It also reduces the voltage coming off of your cathode. And the fact is, these cathodes, they don't really want to get that crazy voltage. If you want to keep your tube safe and not too crazy, keep your cathode voltage when it comes off of a cathode follower under 100 volts. So this helps do that. Of course, when you're just cranking that fucking knob in there, all hell's gonna break loose. But that's what you do. But if you just want to go nuts and then put that 100 on there, you're gonna get the fuzz, but you're gonna get the gain. I should say the volume out of it. But I do like this setup. I'm gonna try it here, see how good it goes. With that said, let's get to goddamn work. Now, the way you build it, because the second half of a cathode follower does not have a plate resistor. You're going voltage directly into the plate of the second half of the actual cathode follower. That side of the tube, plate, no cathode resistor, no plate resistor, and it comes out the cathode. As a kid family saying, it comes out the butt. So we're going to shove this signal out this thing's ass. So we don't have to do all this crazy crap. This is why I left this here. You saw in the previous video, this here. We're going to run this to the plate of the second half of the stage. Then I'm going to run this resistor across. So I stand it up nice and high. So let me see what I got. I'm going to put it underneath here, but I just want to see what kind of length I'm dealing with. I think I can get it here. I just want to strip it before I put it underneath there. So in case there's a problem, I don't beat the hell out of anything. Jesus. Oh, I forgot. This white wire sucks balls. Yeah. It's hard to strip. I was enjoying this blue wire. I was about to say I haven't whacked the camera, but then again I haven't. Jesus, I haven't done any white wire. What the hell is with this? This seriously sucks. I'm going to chop it down with some 22 a little bit. There we go. Yeah, it's white wire, as in the previous video. It sucks. So, I'm going to go here. I think that'll be good. Might even put it underneath there, just to keep it good. I almost want to make that shorter. Yeah, I think I want to make it shorter. I'm going to bring it back out though. So I'm less likely to smash something. All right, let's bring that down. Having such fun getting these things in there. Okay. Sometimes you need some little screwdrivers. Whatever you can get in there that's workable, get in there. Try to keep these straight up. You may have to bend some of these pins to make things work. Okay, now we have our 100-watt resistor. Sorry, 100K resistor. I did that last video. 100K resistor. We want it a little long because we want this thing to stand up high. Because we do not want this in the way. So we're going to go like that. This is a pain in the living ass to do. It's very stressful at times. Because you're trying to get this in there. Okay, we're there. Okay, yeah. Little shorter. Okay, so we can cut this. Cut that. If you can't go in out, then you may want to go one is in out and the other one is out in, meaning this one's going from the inside out. We may have to go that one from the outside in just because the fact that it's just not going to comply in any goddamn way. I mean, to do it both inside out, good luck. It is not going to be easy. I don't know where my little wire cutters are with little points. One, two, three, four, five, six. Yeah, 6. Wait, am I doing this right? Yeah. These are the things, if you do wrong, That's hard to fix. Very, very hard to fix. And I'm about to do something even crazier to this thing, which makes it even more fun. Okay, now let me just make sure, get in my head. First stage, boom, plate, we're gonna connect more shit. But this is the first plate. First plate has nothing but power. So let's solder that in, because at least make it stand still. Do this in a well-ventilated area. That's why I'm in the barn. I used to do it in the kitchen, but I had a great extractor in my house, so it was okay. Because trying not to breathe this shit in, it's not good. Okay, so we have power. The second half of our tube is now powered. We also have the 100K going to the plate, which works standard for the first half. So we got the 100K resistor there. Now what we need to do is we need to send this signal to the other side, which normally you could literally just run a wire over to it, which would be the 2. Remember, 2176. So we're going to put this into the grid, but this is where the safety crap comes in. I need a 100 ohm resistor, which apparently I don't have. What the shit? I'm out. Well, this is bullshit. Okay, well, shit. Apparently I didn't order any. And it's another thing that I'm missing. Let me see what I'm gonna do. I got my 1 ohms. I don't have any 10 ohms. I've got 10 ohms. I got 220 ohms. I do not have any 100 ohm resistors. Well, shit. This is what happens when you don't order shit. So crap. Well, we're gonna do the most we can on this one. We're going to do the second half of it, and next week, apparently I have to get some more resistors. I just try to order shit. Okay, well, I don't know why I don't have any. I mean, literally I've only done this once, and I have a thought for them, so I don't know if I lost them or what the hell happened. But I have a couple choices. Either bypass it, don't do it at all, which has been done for a long time. But, you know, I want to show you new things and show you how to do stuff. So I'm gonna wait, and I'll put it in later. We can still move on and finish this part of it. So we're just gonna pretend that it's connected. We're not gonna turn on anyways. So next week, I'll show you that. I'm gonna hook this crap up. And here we go. You ready to go back, kid? We're done with the crazy shit. Yeah. Yes, I am. Okay, I'm gonna drink a beer because I'm irritated. Where are we at? Drop the schematic on the fucking floor. Or this is the data wiring diagram. Okay, kid, where are we at? We can connect the 2 cathodes and then run the capacitors to the tone stack, and we should be fine. Okay, cool, dude, kid. Let's do it. Let's keep this up so you know your numbers. So the first cathode is the 820 ohm. 847K. We will bring both of them to ground. It's too far. We'll have to run a wire to the ground because the bus is too far. Right. Eight 820 ohm. We need a 47K. These are very big and they're blue. Holy crap, I forgot I had these. These things are insane. Yeah, if you want like super mega power, but the fact that it's coming off of the cathode, in order to drive the shit out of it, might as well go big. And because it's not really in the signal path, its type isn't really that big of a problem. But if it is, we can always replace it. I have another one, I'm not 100% sure what type it is. Okay. Wow, this is super, super big. All right. Yeah, it's too long. Yeah, I'm afraid it doesn't touch the bottom. Alright, so those are the cathodes. Now the difference, this cathode is going straight to ground. This one, because it's a cathode follower, it's going to come off of here, but this will be grounded. The signal is coming off the cathode, so this is pulling the voltage to the cathode, so we're going to go down, and the capacitors are going to come off of here. So one thing we're going to do is, let's connect this one to ground, just so we can hold these things in there. Okay, I will. Oh, that sounds good. All right, get your butt in there. Now, when you're doing these things, sometimes you got to bend these out of the way because we have a capacitor that's going to go from here to there. So, oh, not that. It's not working either. So, we'll just try to push it with a finger and try to burn ourselves. Okay. All right, that was good. Move it to here. That's way longer than I need. Like I said, I'm not the cleanest person to do this, but you see what I'm doing. Look online, you'll just see some people with some amps that are ridiculously clean. But at the same time, if I need to do repairs, I got a little bit of length. The ground's not going to be a problem. You more or less want to keep them short when you're dealing with your signal wires. Okay. Do we need to solder this one in? Yeah, kid. You gotta solder that one in. Were we waiting for something? I don't. Let me look. No. This should be soldered. All right, let's get paper soldered. Okay. Okay, so we need a 470 picofarad capacitor and a 33K resistor to go through there. This is spreading it for the tone stack. That's going to go here. Like I said 470. And a 33K resistor. I have one left. Okay, we need to hook that to the cathode of this side. Pin 3. Where's the wire? Okay, we're connected. We should jump over a little tall so we don't get signal crossover. There, not so much. I think you should chin this baby, man. I tin it. You see me do that on the last video. Basically, it makes it more of a straight wire, less what do you call it? Stranded. Because this baby is crowded. Okay, I just moved him. This is where the solid wire is a little easier. it fits down in there, and technically it's actually a little bit smaller. I got a bit in there. There we go. Okay, kid, you're getting her done. Now we gotta run it. What are we doing now? We need to run the capacitors from here to there. What kind of capacitors? The 0.022 to go to the mid and the base. Okay, now there's a lot of different tone stacks. Marshall type uses 2.022 on these things. You'll see in a lot of Fenders, you'll see an 01 and 047 in these positions, but they like to use the 0.022, and that's what we're using for this. It's right here, this 470, that's your treble pot. It gets split up here into these two, and it's kind of a crazy wiring. That's what we're going to do. Like I mentioned in another video, the tone stacks on schematics are not wired as they look on schematics. So go find the tone stack you want, find a wiring diagram. If you look at just the schematic, it's not going to show you right. Go find something that has a wiring diagram, because a lot of times it is just straight up wired differently than what it shows. They show everything connected. There are some that show some really crazy tone stacks that probably are right, but if you're looking at your standard ones, they're not wired as they look. Okay, let's do the tone stack. We have treble, mid, and bass. We're going to wire that through here. The treble goes to here, the middle goes out. We're going to have to do some jumping. Okay, ready. These are a little weird, but we have it. Oh, we're going to connect this one first. Okay, that one is good. We will bring it here. Make sure you have your thing straight up so you know it's going to be a length, because if you do it too tight and it's in the wrong angle, you won't be able to get up. Not that it's going to really matter, but it's always good just to set it up that way. that is too long. I don't know. It's kind of good. It's good like that. Okay. No, I don't like it. I don't like it. No, it's too long. Okay. Cut it then. Okay, we need beer. Yeah, we do. Beer. It's what's for dinner. So we need to jump the ground over to the middle of the base. That is the weirdness that is the tone stack. The tone stacks are kind of funky. Especially if it's set up, it'd be easier if you actually had your bass and your treble next to each other and your middle somewhere else because of the way it's wiring, but it is what it is. So if you can wrap this thing around, wrap it around. Okay, ready? Yeah. Okay, let me jump it here. You cut it a little shorter. Now, we need to come from here to there. Doesn't really matter which one you use because they're both the same. If you're using a different schematic or different circuit, then it is going to matter, and you may want to position them depending on what it is. You know, the middle go to that way and the bass go to that way. I usually have my nails more cut, but it's really working my advantage today. Okay, now we're going to connect to here. Now we need to connect this to here and the ground of the base into the same thing. And then we're going to, oh, you can't see. The ground of the base goes to here. This also goes to here. This gets grounded. We'll run it to there, maybe to the body. But both the ends are not used. Okay. Okay. This is mostly done. We need to ground the mid-range. Okay, we need to ground this and connect this. Okay, kid, it's looking good. You got your mid-range hooked up, your bass hooked up, got your treble hooked up, all grounded out. Got these issues. This we don't have. We're waiting on. We got to build a board. We have to get the 100 ohm resistor so we can finish this up. Actually, we could probably go ahead and hook up that cathode on the first stage. Okay, that sounds good. One, 2, 3, 4, 5, 6, 7, 8. Number 8. 8 and 3. 8 and 3 are cathodes. Okay, now we need to hook it here. This is the first tap of the cathode follower, and it is a 820 ohm resistor. We're going underneath the power. It's DC, shouldn't cause any problems, and it's a cathode resistor, or should a cathode, what's a cathode? So we shouldn't have any problems with that, because it's not in the signal path. It shouldn't be feeding anything back, because it's just some DC. If I had a choice, I would avoid that, but some of these things get a little messy. Okay, one thing you'll notice, which is why I put these so far apart, is as you move down, your circuit's going this way, but not as fast as your tubes are moving this way. So when you have a lot of stages, you end up with this cross. Your circuit's here and your tubes are there, and you end up with all this cross wiring. It's a real pain in the ass. It's, well, not just pain in the ass, but it's a problem with signal crossing. I had, when I was building that one, it's so crowded. It's a three channel amp. It's very difficult to get that much I have a little bit of circuit cross, and I had a problem, and it took me like almost 2 days to figure out what was going on. I had this huge hum in channel 3, and I'm like looking at it, I couldn't find the problem. And I happened to be poking in there while it was live, and all of a sudden it stopped. And it's because I moved a wire. I had a wire that was crossing one of the stages, and the signal was so goddamn hot, because I was like, I think it's like I got like 5 stages in that channel. So when it crossed, it was just transferring so much signal over that it caused a hum. When I moved it over, it stopped. So that's one thing you got to consider when you're how many channels you want and what you want to do. This is why this amp is so nice, it's one channel. You don't get any EQ changes, which is one of the downsides, but you got your cathode cap changing. You have your gain changing. So it's almost like giving you three channels in one. You just don't get to change the EQ in there. So if you want to go that with a little more nuts, I think a 2-channel can be probably a perfect amp in that situation. But I'm looking at this. What do we have? Let's just wire this. One more thing here, kids. You don't mind if I take over? Yeah, it's fine. I'm going to take this over, and let's just wire this last thing up, and we're good for the preamp side, except for the couple of things that you know that I'm missing. So let me just wire this baby up, ground that. He's ground here. Actually, all we got to do is ground it up. Yeah, so we just got to ground it up and good. There's ground wire here. It's yeah, should be that one, that one, that. You know, if you're not sure, here, let's do this. I want to show you something. Now, you're shunted. It's like here, this. They're connected because it's shunted. Now, if of course, it's a little difficult. I push it, it's not shunted. But they're not shunted to ground. Like that. That's ground. So we actually have connection, barely weak connection, but it is to ground. Once we get a good connection, these aren't actually grounded. We need to run this to actual ground. So we're going to run this to an actual ground at some point. So that is grounded to the chassis. This is your signal ground, then you ground your signal ground to the chassis. But this is your ground. Now the difference is, this one is shunted. Now we're going to wire this to ground, so when it is shunted, meaning there's no plug in here. So when there's no plug in, you want to ground, which will ground your tube straight to ground. That's it. It's ground. Well, it's got the 68K resistor, but that's not a whole lot. It's going straight to freaking ground, so we're good. So we're good. So we're going to do that. When you have, like, for your, you can't see it over there, but for your output jack, we're going to take a safety resistor, and instead of going shunting, you know, wiring it straight, we're going to take a safety resistor. About 16 ohms, see if we can get a decent amount of wattage on it. That way, if you don't have it plugged in, it's not going to cause any problem. If you don't know, your tube amp has to have a speaker plugged into it when it's on. It's not going to necessarily kill it. You do it once or twice, but it is bad and it can fuck up your amp. So what you do is you put your safety resistor in there. So if you forget to do it, you got your 16 ohm, which I would suggest 16 ohms because, you know, because if you have an amp that you have a selector 4, 8, 16, you always want your impedance of what you're driving higher than the impedance of your output transformer. So just get a 16, that way if you're doing it, I know, well, if you're going to just hardwire it like these ones, I'm going to hardwire it. I'm not going to put a selector in there, but if you put a selector in there, get a 16. But I'm just going to get a 16 ohm anyways, just in case I change that in the future. So you do that. That way when it's shunted, it shunts through the resistor and into that. Now, if you're over there driving the crap and going, well, my speaker isn't working, or whatever, you're probably going to blow your resistor because you're not going to get one strong enough. So it's one of those things you're like, oops, you're fine. It's an oopsie-doo. It's nothing more than that. So let's wire this baby here. I like this little screwdriver. It does help to bring it over in those places you can't quite get to. Okay, now we just got to run it over here to the bus bar. Get all right up in their business. So we can probably cut it right there. Too many cord cables over here. Over there, let's turn my, let me get this out of the way because it's annoying the shit out of me. Okay, we're good with that. I'm gonna trim it there. I should probably get that shorter. A little bit shorter. And we're gonna screw it. I don't know what I do with my screwdriver, but there's. Got a little crowd over here. See what I'm doing? I'm trying to get this to go in there, go underneath, and bring it up. That's probably good. It feels nice and tight. All this thing's nice and wired together. It's a little clumpy, but it's clumpy because it's stranded wire and I've got it really wound up, or I should say wrapped. So it looks like we're good. This actually isn't that bad. These could be shorter. I mean, we're fine, but at the same time, I don't want them to cross, so I like to have it a little more jumped over. So I'd rather risk a little bit of oscillation than having some crossover. I think we're good. We have our power in. We got to deal with that. We got the power amp, but quite frankly, there you go. Now, if we just had a cathode cap resistor right here to ground, this would be standard. Let me show you that. So we have, get your cathode cap right here, straight ground on your first stage, and that's normal. But we're not doing that. We're going to be doing something else, which we've explained. So I think we're good. See you next week when my parts come in and we can finish this baby.